Hey guys, so in this video we're going to go over number 6, 7, and also number 15. So 6, 7, and then, is it 15? Yeah, 6, 7, and then 15. Okay, so number 6, we want to know if x is defined at 2. So the first thing that I would do is I would plug in 2 to the part of the equation that it fits in. So if I want it to be equal to 2, I'd have to plug into the bottom part. So it'd be f of 2 equals 2 squared minus 4. 2 squared is 4. 4 minus 4 is 0. So is f defined at 2? Check. Yes, it is. Okay, the second thing it asked me to define is if it's continuous at 2. So remember, for continuity, you could get out your definition, but the first thing you have to check is that f of 2 exists, which we just found it was 0. The second thing that you have to do is check the limit as x approaches 2 from the left, and the limit as x approaches 2 from the right. Remember that these limits have to be equal to each other. So the left limit is going to be the top part of my equation right here. So that would be the ln of 2 squared minus 3. And then on the bottom, I already plugged in 2 and I got 0. So let's see on the top if these come out to be the same. So if this is the ln of 2 squared minus 3, that's really 4 minus 3, which is the ln of 1. And hopefully you remember from yesterday that if I need to find out what the ln of 1 is, I need to think about, let me do some scratch work right here. If the ln of 1 equals something that I don't know, then I could do a base e and say e to the what equals 1. So it'd be e to the what equals 1. Well, the only exponent that I can put on e to get a 1 would have to be a 0. So this actually is 0. So my y value is 0, my left limit is 0, my right limit is 0, my step 3 is that those things have to be equal to each other, which they were. So I would say then f of 2 equals the limit as x approaches 2. Therefore, yes, it is continuous. Now, let me also talk about, remember, this is a left limit, this is a right limit. In my step 3, I no longer have a sign on it. That's the limit from both sides. Okay? Alright, your next part we have to check is if it's differentiable. Remember, to check if it's differentiable, it has to be continuous, which it was, and then my derivatives from the left and the right have to be equal to each other. So I'm going to take the derivative of my piecewise function. So if I take this right here, f prime of x is going to be the derivative of ln x squared minus 3. Well, remember, that's going to be u prime over u. So if this is my u in here, then u prime is 2x over u is x squared minus 3. That would be for x less than 2. And then for greater than 2, I'd take the derivative of the bottom part here, which is just a 2x. That would be for x greater than or equal to 2. Then from there, I would need to check the limits of the derivative, so kind of like I did here, but with f prime. So, pretend this isn't here. I'd find the limit as x approaches 2 from the left of f prime of x, and I'd be plugging into this. So on top, I'd get 2 times 2 is 4, over 2 squared down here is 4 minus 3. Okay, well 4 minus 3 is 1, so that's just 4. Then I would take the limit as x approaches 2 from the right-hand side for f prime of x, which means I'd be plugging into this piece. 2x would be 2 times 2, which is also 4. So if these guys come out equal, that means that my left and right slopes are the same. And remember, that's the definition of it being differentiable. So 1, 2, and 3 are all true. Next one. Okay, number 7. If you did this based on your long rules, it actually is still possible, but there's a very easy simplification that you can do on this one that makes the problem a million times simpler. So when I have this, e to the 3 ln x squared. Okay, there is a rule if I cover the e up here. Okay, the rule is that I can take this 3 and I can apply it as an exponent here. So rather than looking at this as 3 ln x squared, I'm going to look at it as the ln of x squared cubed. Now, x squared cubed would be x to the 6. So really, this is ex to the 6, right? Okay, now what we learned yesterday is, well, actually you learned it in pre-cal, but we reviewed it yesterday, is that e and ln cross each other out. So really, this is just an x to the 6. And so if that's my f of x, all that I want is f prime of x. So f prime of x would be 6x to the 5th. Now, there is a longer way to do that using all of your rules, but you end up needing to use this step anyway. So remember, anytime that you have this, that is the same as log base x to the n, where you take that and you apply it as an exponent right there. Okay? Turn the page. The next one we're going to do together is number 15. Which is kind of out of order, but you get the idea. Now, I'm not going to do all of this one, but I'm going to do part of it. So the first thing you should notice is it's asking you to take the second derivative. So that means we're not only taking the derivative once, we're going to have to take it twice. So f prime of x is going to be the derivative. I'm going to need to use chain rule here. So I would take my 2, I would multiply it down to the front, so now it's 2 ln x to the 1. But then I have to times by the derivative of the middle, and the derivative of ln x is 1 over x. So my equation for f prime of x is 2 ln x times 1 over x. Now, from here you have two choices. You need to take the derivative again. So you can use product rule, or you could write it like this, 2 ln x over x. And it doesn't really matter which way you do it. In this case, you would be using product rule. In this case, you would be using quotient rule. I think I'm going to go ahead and use quotient rule. This is why. When you look at your answers, do you see how every single one of them is just one fraction? Okay, if I do this method, I'm going to have to simplify a bunch at the end to try to make it one fraction. So even though it's not wrong to do it as a product rule, I think that our end game will be a little bit easier if we do it like this. So my high is going to be 2 ln x. My ho is going to be x. Well, then my d high is going to be 2 1 over x. My d ho is going to be 1. So that makes f double prime of x. Ho d high would be 2 1 over x times x minus. High d ho would be 2 ln x and then times 1, which you don't even have to put if you don't want to. Then divided by ho squared would be x squared. Then from here, I notice that it's very obvious that these are going to cross out, so I'm going to go ahead and do it. But I wouldn't try to do a ton of simplifying here just because it's not worth it. So I'm going to have 2 minus 2 ln x over x squared. And then specifically, I want square root of e to be plugged in. So I'm going to find f double prime of e to the 1/2. So then I'd have 2 minus 2 ln e to the 1/2 over e to the 1/2 squared. And then what we talked about yesterday is that ln and e, these guys here, can cross out with each other. So they're gone. So really I want 2 minus 2 times 1/2. And then on the bottom, if this is e to the 1/2 times 2, well then I multiply 1/2 and 2 and I just get an e left over. Then 1/2 of 2 gives me 1. So really this is 2 minus 1 over e, which is 1 over e, which is answer choice A. Okay? Good job.